Hello. In this video, we are looking at another finding the volume of a solid example, but in this one, we want to set up, but not evaluate, the integral that is needed to find the volume of the solid whose base is bounded by the curves y equals x and x negative x squared plus 4x, and whose cross sections perpendicular to the base and parallel to the y-axis are semicircles. So first, we want to figure out where this base is bounded on the x-axis. So we have the area between these curves y equals x and y equals negative x squared plus 4x. So when x equals negative x squared plus 4x, we have that x squared plus x minus 4x equals 0, or x squared minus 3x is equal to 0. Factoring, we get that x equals 0 or x equals 3. So our points 0, 0, and 3, 3 are where those two functions intersect. So we know we are going to be finding the integral from 0 to 3 of whatever the area function in terms of x is. We need to find what this area function is. We are looking at semicircles, so when these slices are made, we are getting a face looking like a semicircle. In a semicircle, we know the area is going to be pi r squared. For a whole circle is pi r squared. For a semicircle, that's half. So pi r squared over 2. Finding what r is, we know that this full base is the distance between our parabola and our line. So that full base is negative x squared plus 4x minus x. Or negative x squared plus 3x. That means the radius is half of that. The radius is going to be negative x squared plus 3x divided by 2. Meaning our area function is pi times negative x squared plus 3x over 2 squared all over 2. Simplifying this down, we have pi over 2 negative x squared plus 3x over 2 squared, or pi over 8 times negative x squared plus 3x squared. There is our area that we can plug into our integral, saying that our integral is the integral from 0 to 3 of pi over 8 times negative x squared plus 3x, all of that squared dx. And that integral, when solved, will find the volume of the solid whose base is bounded by the curves y equals x and y equals negative x squared plus 4x, where we have semicircle slices when slicing perpendicular to the base and parallel to the y-axis.